Hello students, welcome back. Hope that you are finding the videos useful in learning the concepts and solving the equations. In this video, let us learn method 3 to find integrating factor and solve non-exact differential equations. Okay, I will be solving two exercise problems from JNTU textbook. Okay, so let us understand what is method 3. What it says is, if the equation m dx plus n dy is equal to 0 is of the form y into f of xy dx plus x into g of xy dy is equal to 0 and mx minus ny not equal to 0. So that means we are talking about two conditions. The first condition is it should be of the form y into f of xy dx plus x into g of xy dy is equal to 0, and the second condition is that mx minus ny is not equal to 0. In that case, 1 by mx minus ny is an integrating factor of m dx plus n dy is equal to 0. So after finding integrating factor, what we will do? We will use that integrating factor to convert this non-exact differential equation into an exact differential equation and solve it, isn't it? Now problem 1, solve y into 1 plus xy dx plus x into 1 minus xy dy is equal to 0. So let us call this as equation 1. So this is of the form, equation 1 is of the form m dx plus n dy is equal to 0, isn't it? Where m is equal to y into 1 plus xy and n is equal to x into 1 minus xy. So this is nothing but y plus xy square and this is x minus x square y. Now to find equation 1 is exact or not, we have to find the partial derivatives dou m by dou y and dou n by dou x. So dou m by dou y is derivative of m with partial derivative of m with respect to y. So this is derivative of y with respect to y is 1 plus x is treated as constant. So x into derivative of y square is 2y. So this is 1 plus 2xy and dou n by dou x. So derivative of x with respect to x is 1 minus y is treated as constant, derivative of x square is 2x into y. So this is 1 minus 2xy. So this means that dou m by dou y, this implies dou m by dou y is not equal to dou n by dou x. So this implies equation 1 is not exact. So we have to find the integrating factor, right? So but equation 1 is of the form y f of xy dx plus x g of xy dy is equal to 0, isn't it? So y into some function of xy, f of xy, and plus x into function of x of xy. So g of xy dy is equal to 0. And what is the second condition? If it is of this form, we have to find whether mx minus ny is equal to 0 or not. So what is mx minus ny? M is y plus xy square. So y plus xy square into x minus what is n? X minus x square y. X minus x square y into y. So is equal to, this is xy plus x square y square minus xy plus x square y square. So these two gets cancelled out. So this is 2x square y square, which is not equal to 0, right? Therefore integrating factor will be, therefore integrating factor is if is nothing but 1 by mx minus ny which is nothing but 1 by 2x square y square. Now what we will do? We will multiply the given equation 1 with this integrating factor 1 by 2x square y square, so that equation 1 gets converted into an exact differential equation, right? So multiplying equation 1 with 1 by 2x square y square, we get 1 by 2x square y square into this is y into 1 plus xy, the numerator y into 1 plus xy dx plus 1 by 2x square y square into x into 1 minus xy, x into 1 minus xy dy is equal to 0. So here we can simplify it. 1y gets cancelled and 1x gets cancelled. This implies 1 plus xy by 2x square y dx plus 1 minus xy by 2x y square dy is equal to 0, right? Let us call this as equation 2. So equation 2 is of the form, equation 2 is of the form m1 dx plus n1 dy is equal to 0. So we can prove that equation 2 is exact. Therefore, the general solution, if you want, you can again do it, what is m1 and compare it and find dou m1 by dou y and dou n1 by dou x and show that they are equal. Thus, we can show that they are, it is an exact equation. Equation 2 is exact. Alright. So, because once it becomes exact, we can find the general solution using therefore, general solution is given by integral m1 dx, where y is constant, plus integral n1 dy, and here we will consider only those terms free of x is equal to constant. So this implies what? Integral, what is m1? 1 plus xy by 2x square y dx. So you have to treat y as constant, plus integral. Now let us check what is n1. n1 is 1 minus xy by 2xy square. So when you separate the terms, it will be 1 by 2xy square minus xy by 2xy square, right? Two terms. We can separate it as two terms. So in the second term, xx gets cancelled out, so the second term will be independent, and y gets cancelled out in the denominator. So what remains? Minus 1 by 2y remains, so which is independent of x. So this is minus 1 by 2y dy. is equal to constant of integration. Now let us solve this integral. So because y is treated as constant and 2 is also a constant, we can write outside the integral 1 by 2y integral 1 plus xy by x square dx, and this is minus integral, okay, 1 by 2 also is a constant, we can write outside 1 by y dy is equal to constant of integration. So this implies 1 by 2y, we can write it as two terms, right? Integral 1 by x square dx plus integral xy by x square dx minus 1 by 2. Integral 1 by y is log mod y is equal to constant of integration c. So this implies 1 by 2y integral x to the power of minus 2 dx plus 1x gets cancelled out, 1 by 2y integral, y is a constant, so you can take it outside, so y 1 by x dx minus 1 by 2 log y is equal to c. So this implies 1 by 2y, this integral of x to the power of minus 2 is x to the power of minus 2 plus 1 by minus 2 plus 1 plus this y gets cancelled out, so this is 1 by 2 log mod x minus 1 by 2 log mod y is equal to c. So what is the formula that we have used for this integral? Since integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. This is the formula we have used here. So this is minus 2 plus 1 is minus 1, right? So minus 1 by 2, and this is x to the power of minus 1, so we can write it as 1 by x, so 2xy, we can write it as minus 1 by 2xy plus 1 by 2, we can take common in both of these terms, so log mod x minus log y is equal to c. So this implies you can take 2 common from both the terms and take it to this side, so it becomes 2c. So minus 1 by xy plus, and log x minus log y is log x by y, isn't it? So log modulus x by y is equal to 2c, or you can simply write it as, I am writing the positive term first, log modulus x by y minus 1 by xy is equal to c. Instead of 2c you can write, because anyway both are constants, so you can write c, and this is the required solution. Problem 2. Solve y into xy plus 2x square y square dx plus x into xy minus x square y square dy is equal to 0. Let us call this as equation 1. Okay. Equation 1 is of the form m dx plus n dy is equal to 0, where m is equal to y into xy plus 2x square y square and n is equal to x into xy minus x square y square. So this is nothing but x y square plus 2x square y cube, and this is nothing but x square y minus x cube y square. Now dou m by dou y is this is 2xy plus 2x square into 3y square, isn't it? Is nothing but 2xy plus 6x square y square, and dou n by dou x is 2x into y minus 3x square y square is nothing but 2xy minus 3x square y square. Thus we can see that dou m by dou y is not equal to dou n by dou x. So this implies equation 1 is not exact. But we can observe that the given equation is of the form, but equation 1 is of the form y into f of xy dx plus x into g of xy dy is equal to 0, isn't it? So this is y into some function of xy plus dx plus x into some function of xy into dy is equal to 0. And let us find what is mx minus ny. What is m? M is this one, right? X y square plus 2x square y cube into x minus what is n? This is n. X square y minus x cube y square into y is equal to, opening the brackets, this is x square y square plus 2x cube y cube minus x square y square plus x cube y cube. So these two gets cancelled out, and this is 3x cube y cube, which is not equal to 0. Therefore integrating factor is equal to 1 by mx minus ny, which is nothing but 1 by 3x cube y cube. Now what we will do, we will multiply equation 1 with this integrating factor. So multiplying equation 1 with 1 by 3x cube y cube, we get 1 by 3x cube y cube into y into this, right? Y into xy plus 2x square y square dx plus 1 by 3x cube y cube into x into xy minus x square y square dy is equal to 0. So this implies 1y gets cancelled, this is x cube y cube, right? 1y gets cancelled and this 1x gets cancelled. So this will be 1 by 3x cube y square. In the numerator what we will have? Okay, xy plus 2x square y square dx plus in the numerator after this gets cancelled out, what remains? xy minus x square y square, right? In the denominator we have 3x square y cube, and this is dy is equal to 0. Let us call this as equation 2. Now this is of the form m1 dx plus n1 dy is equal to 0, right? Equation 2 is of the form m1 dx plus n1 dy is equal to 0, and we can prove that equation 2 is exact. Therefore, general solution is given by integral m1 dx, where y is constant, plus integral n1 dy, where n1 is containing only those terms free of x is equal to constant of integration. So this implies what? Integral xy plus 2x square y square by 3x cube y square dx, y constant, plus, now in n1 we should get only those terms which are independent of x. So when you write this as two separate terms, so only one x gets cancelled out, right? So in the denominator you have one more x, so this first term is not independent of x. So this x square minus x square y square by 3x square y cube. In that x square gets cancelled, two y's gets cancelled out. So in the denominator you have only one y. So therefore what remains? Minus 1 by 3y remains, right? So which is independent of x. So this is minus 1 by 3y dy is equal to c. So this implies, now writing this integral as separate terms, integral xy by 3x cube y square dx, y constant, plus integral 2x square y square by 3x cube y square dx. Again in this y is constant, right? Minus 1 by 3 is a constant, integral 1 by y dy is equal to c. So this implies, in this 1x gets cancelled out and 1y gets cancelled out, and y is a constant and 3 is a constant. So you can write outside the integral 1 by 3y, integral 1 by x square dx, plus y square gets cancelled out, and 1x remains in the denominator, 2 by 3 is a constant, integral 1 by x dx minus 1 by 3, this is log modulus y is equal to c, isn't it? So this implies 1 by 3y integral x to the power of minus 2 dx plus 2 by 3 log modulus x, right, minus 1 by 3 log modulus y. So this implies 1 by 3y x to the power of minus 2 plus 1 by minus 2 plus 1 plus 2 by 3 log mod x minus 1 by 3 log mod y is equal to c. What is the formula that we have used here for this integral? Since integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. So this implies this is minus and this is x to the power of minus 1 is 1 by x. So this is minus 1 by 3 xy plus 2 by 3 log mod x minus 1 by 3 log mod y is equal to c. So in the denominator 3 is common, right? So you can take 3 and cross multiply, it will become 3c, or you can write it as 1 by minus 1 by xy plus 2 log x minus log mod y is equal to 3c, or you can write it as minus 1 by xy plus log x square minus log y is equal to 3c, or you can simply write 3c as c, or you can write it as minus 1 by xy plus log a minus log b is log a by b. So this is log x square by y is equal to c, or writing the positive term first, log x square by y minus 1 by xy is equal to c is the required solution.